Hey everyone, this is your weekly episode of the Zephyr podcast, where we talk about all things Zephyr, RTOS, embedded, open source, hopefully lots of other cool stuff. I'm Benjamin, your co-host.
And I'm Fabio, your other co host. Benjamin, when is the last time you ran out of flash?
Haha. Myself, I don't know. It depends on the boards I use,
If
for
you
sure. And
if you have a
that's
limited amount of flash and you run out of flash, the value of any saving of flash is infinite because you have devices in the field. There's no money in the world you can buy you more flash. Well, I mean, I guess you can replace them anyway. You did something.
yeah. I've been spending some time uh, refreshing, I guess, some work from a few months back. But yeah, usually one reason why something might not fit into Flash is that you're logging too much, or you have like too many strings, basically, that you need to maybe cut a bit here and there to try and make it work. I mean, sometimes Flash isn't an issue in some really big boards, and sometimes it is, and it's a nice convenience, right, to be able to log and use the shell, etc. For logging, I think we have something actually that's quite interesting and quite useful, which is like dictionary-based logging sort of stuff, where you can have, rather than embedding the actual full strings in the firmware, you have like short, like
Very
really short, actually.
extremely effective and extremely inconvenient.
Yeah, you need scripts to then do the decoding, and like you cannot really
and you
make
need
sense of what's going on in real
and you
time.
need
Uh,
the dictionary for the build that you deployed.
yeah, but we have some really great tooling for that, and like that's certainly you save a lot of flash.
Oh yeah.
Like every string ends up being basically just uh, a couple bytes instead of being the full strings. So that's one solution for logging. Another angle, I guess, is that you want to make sure that there's no duplication. Like all those strings, especially we see it a lot in shell commands that sometimes happen to have also like help message associated to them. There's lots of repetition there, like usage colon blah blah blah, and like, I mean, this is something that might be repeated over dozens and dozens of commands, and yeah, unless you do some smart tricks, you're eating up hundreds of bytes of flash this way. So a few months back, I think a new macro was introduced to help avoid some of the repetition. So the shell help macro is something that basically I encourage people to have a look at. And I realized, I'm not sure what triggered it, but I realized that some shell modules in the tree hadn't been migrated just yet to this new sort of like macro that does a lot of magic under the hood, including the ICCC shell, which when you do adopt this new magic macro, you save over 1 kilobyte of flash, which,
Wow. Wow.
yeah, which are arguably, like, in fairness, or in like to be fully open there, maybe in those systems where you have ICCC and you can afford a shell in the first place, maybe you don't care about saving 1 kilobyte of flash.
You don't
But
care
yeah,
until you get to the limit,
until
right?
two, yes,
The
yes.
stupid thing I said in the intro, it's kind of true, right? That wow,
Yeah,
just
and when it doesn't fit, it doesn't fit. Like it's a RAM, you can try and get away with, hey, maybe this will work, maybe this won't overflow. I mean, Flash, if it doesn't fit, then you don't get your binary, right?
yeah. When you sent me the pull request mentioning the saving, I was like, nah, you did the math wrong, can't be. But no, it was true, and in fact, we do have a situation with our application, the embedding controller firmware, where yeah, we do have the flash enabled in the production firmware, and we have the help text, and we are short of flash, pretty much in many platforms. So I actually took your work on changing using the shell help macro and applied it on our code base. I fixed all of our instances. Wow, that was cool. Yeah, I got in some platform. I also got a saving of a whole kilobyte of flash. And you may think it's not a big deal, right? Like you're usually replacing at first sight you're just replacing a bunch of usage colon space string, but then in their place you're gonna have a couple of pointers, right? But then it's not just that, right? You have the usage string, you have the name, the string containing the name of the command itself, which is repeated every time. And even better, if you have a subsystem with a lot of commands and subcommands, you're probably going to have the same argument for a lot of them.
Yeah.
And then string with the argument, if it's the same, like port, is going to be deduplicated by the compiler once it's in a string by itself. So it adds up, and it's very
Yeah.
cool. Good job. I don't know if did you envision flash saving when you did that feature or just coherency?
Yeah, it was more like stuff like flagging what is the actual help message, like getting rid of all the variations there were in trees of like usage starting with a capital U and like so that yeah eventually I think we mentioned it last week so that eventually maybe we could generate some kind of like well structured documentation where it's really about uh, uh, the actual payload if you will of the help message as opposed to the syntactic sugar around it. But yeah, no, that yeah, flash saving and also just in general for most shell modules that have been migrated now, not only do they eat up less flash, but it makes also the help messages they are more complete. Like basically
Yeah,
all those areas where people forgot to uh, to to document the usage. I mean, most of the usage is now. I mean, it's automatically generated.
it's
So, yeah,
it's a great
that
feature.
made me think.
Yeah, it would be tempting to suggest to have that built in the normal shell macro, so that you have to use it all the time, which would allow you to save another couple of pointers. And then it's 2 pointers per every command. You may have 100 or more for every sub command, so that may give another kilobyte of saving.
Yeah. Yeah, I guess the challenge is that we still have there might be some comments that are dynamic, and for those you need the
Yeah.
solution that's maybe not macro based. Yeah, I don't know, but something else that made me, I mean, it made me think again. Like there's logging and shell. One could argue that those strings they don't necessarily end up in production code. So yeah, if you can optimize, that's great. That helps when you're sort of in debug mode. But then in production code, you might still have some strings as well, where there might also be some duplication here and there. So I was wondering, and there might be some tools out there, or maybe we need to add something to West or something like West strings, or I don't know, something like that. That looks maybe at the ELF file and like look for those strings that look similar and suggest, hey, you know what, you might want to use a format string here instead of I don't know, like device initialization failed, device initialization retried. I mean, those are two strings
Or
that are
at, at,
mostly the same.
at least use the same, right?
Yeah, yeah. Or we need to put some defines, some macros
I was
somewhere
thinking.
for those generic format strings. That, but yeah, but then until everyone uses them, you don't really get the benefit.
Yeah,
But yeah.
very good.
But yeah, that's interesting experiments, and I'm sure there's some tools out there if folks are aware of like scripts and commands available. I'm sure GitHub is full of those
Yeah.
tiny tools. I would love to hear about them. So let us know in the comments tools to optimize and strip duplicated strings in ELF files and whatnot. But yeah, that was a fun
Great job.
experiment, I guess. In industry news, like, was there anything you spotted this week in the news?
We both did apparently. Expressive is at it again. Wow.
Hmm.
So they just
Is it RISC-V this time,
it
or is it?
it is a RISC-V. So they announced the ESP32C5. And I think they're gonna do the whole thing, the modules and the bird chip. So very good chip, RISC-V. So this is Wi-Fi 6 with dual band support. So it's gonna be 2.4 and 5 gigahertz, which I very much like. And it seems to be already available on distributor, so I found it on Mouser already, which is really cool. Seed Studio have their own Xiao board, which is also nice and compact. It looks like they're going for an interesting configuration. So on the chip, you can have either on-chip flash or on-chip PS RAM, and it's gonna have like 8 MB of PS RAM. I don't know how useful it's gonna be because it's gonna be on the SPI bus, on a quad SPI bus. But
Hmm.
and if you want both, like the shell board has, apparently you have to pick one and get the other one off board. But it seems like a very interesting configuration. So solid,
Yeah.
solid Wi-Fi, solid connectivity thing, and
And this will make, like, this setup you just described will probably make for interesting Zephyr. I mean, I'm expecting the pull requests to come anytime soon. I'm
oh,
assuming, I don't know, but like
yeah, it's not there yet.
Espressif and maybe Seed are probably working on that. But it'll be interesting to see how this looks like in terms of yeah, dealing with the fact that the RAM and or the flash might be external. It'll make for interesting variants and whatnot.
Yeah, I'm assuming it has execute in place for both, right? But
Hmm.
yeah, we'll have to be seen. But it seems like a good platform. What I like about the C3, which I used before, and it seems the C5. I took a peek at the schematic for the shower board. It's relatively simple to do a board. Look, I know that most people for the ESP32 they use the module with the embedded RF part and antenna already done, so they can just put it on the board and it works. But you can do a board with this. I did a couple of boards with the C3, and as long as you follow their guidelines, and you have to follow them, it works. This one seems to be fairly simple as well. You have to have a diplexer for the antenna. It's called single antenna, two outputs. But beside that, good product. I like it. I'm looking forward to see the Zephyr support because it's not there yet. It's just been announced. It's very cool.
Yeah, yeah, it is. So yeah, that's the hardware front. Another bit of news that I think I saw on LinkedIn initially, but Daniel Stenberg from the Curl project, well, they announced that basically they have a problem in their community, which is, I mean, Curl is potentially, I mean, people are always looking and sometimes finding, I guess, vulnerabilities in curl, and that's certainly, I mean, we want those fixed, and this can sometimes cause lots of trouble. And they have even a bug bounty program in place. But it turns out that this attracts maybe the wrong kind of people to some extent, or at least the project seems to be having issues with AI slop and like people opening way too many invalid, I guess, issues and sending fixes that are not effectively fixes. So they are, yeah, shutting down their bug bounty program at the end of the month, which I
Sad.
don't know what to think. I mean, I don't. I mean, I certainly they it must be really bad if they're going there. But it's also unfortunate because I think we see some, or I see personally, I should say, some areas where yeah, sometimes AI does help spot smelly areas in a code base or like smelly patterns, and there might sometimes be good reasons for whatever is the smelly thingy. But sometimes yeah, there's real problems it helps uncover. So yeah, I'm not sure. One thing that I will do actually next week, shameless plug, for those attending FOSDEM in Brussels next week, a reminder, I think we said that last week already, but on the Friday before, so in exactly a week from now, on the 30th, there is a Zephyr meetup organized in Brussels, Friday afternoon. I'll be giving a short talk, sharing my, again, personal experience, take it with a grain of salt, but personal experience around all things LLMs and like how it can or cannot help you write Zephyr code, review Zephyr code, help with documentation stuff and whatnot, and trying to share the good, the bad, and the ugly. But yeah, I don't know. What do you think, Fabio?
Well, it's a tool, right? You can use it in the
Yes.
right way or in the wrong way. It's a shame that it looks like. I mean, obviously, if you put something in the wild and it's a bounty, and like you put a bounty, you're gonna find on the internet people that are gonna use it in the wrong way. There's not really much you can do about it. So I have to
Yeah, yeah.
say.
But yeah, and I didn't look whether because I'm pretty sure there's at least one. There has to be at least one bug somewhere in curl that someone uncovered using the tool, like you said. But if it's only one among like hundreds of false alarms and bug reports that people need to triage, etc., then maybe that means that's the wrong tool.
Yeah, yeah, well, tough.
But yeah, that's. I mean, yeah, I'll share a few thoughts next week.
Looking for good.
We have a very active architecture working group these days, so maybe we can give a quick update on some of the discussions. The Lin, which I already forgot what it stands for.
I
The
have no idea
uh,
either.
uh, can variant. Yeah, it's a local interconnect network. It's not a can variant.
No,
It's
I wouldn't.
something that
Yeah,
feels like can.
I don't think there's any hard relationship with CAN beside the fact that they're usually deployed together in automotive environment. But
Right,
as far as I know, I haven't really seen Lean adopted as a general purpose thing. Canvas, you see it. It's
right.
definitely
Yes.
popular in industrial application. There's a number of higher level protocol built on top of it. Lean, no, I think it's pretty much confined in automotive. It's a fancy UART essentially. In
Yeah.
fact, a lot of time you're going to have a UART controller that is going to have the necessary electronics to implement a Lean protocol. I think it's just a encoder. But Bricks, the Canvas maintainer, had a few points about how Lean is used. But yeah, it looks like we're going to have a subsystem, which is cool because there's a lot of automotive MCU that have support in Zephyr, and a lot of them have Lean support. Interesting
So yeah,
discussion.
we will be yeah
Yeah,
linking to the pull request, but
yeah, positive
this is
feedback.
looking
So yeah,
yeah yeah yeah.
it's gonna be there.
It's happening. I guess
Yeah.
is the bottom line. Cool. Something else that was I think briefly presented as well. We might even have mentioned it in the past. The proposal to add some macros, I guess, for the cleanup classes. Did you want to briefly like update us
Yeah,
on
this
this
is
one?
this is something we mentioned in the podcast some time ago that exists in Linux. So you can use a compiler feature that is available in GCC, LLVM, and in some of the proprietary compiler we support that execute a function when a variable goes out of scope. And the way it's going to be used is by attaching a cleanup functionality, for example, a free format malloc that is going to be
Mm,
executed when your function is going to return. This is similar to a defer that you see in other languages. So we're not going to be able to use it in the kernel code because the Zephyr codebase has to support a number of compilers. And whenever you use this feature, you have to make sure that either all the compiler do it, supports it, or you have a workaround. And it doesn't look like we're going to have it here. Interesting thing is that the IAR guys apparently saw a reference in the main code base and they just implemented the functionality, which I think it's really funny because like it's an extension. They just did it. This and the functionality, the usage that they found then became optional, so that you can use the code for other compiler. It was just a validation, so it wasn't really that important. But yeah, Peter is working on having support for these for your application. So if your application is using GCC or LLVM, you will be able. It seems like it's going to go. There hasn't been any pushback on the specific implementation, just how to make it sure that we don't accidentally use it on the core code. And yeah, you'll be used to have a cleanup using this macro, which in some situation can clean the code, can result in more readable code. Um, it may not be the best thing for like I would expect it to use it everywhere. There's been some comment that even in the kernel in Linux where it's used a lot, it's not used in the networking subsystem. Not super clear to me why. Someone in architecture review mentioned that it was for questionable performance implication.
mm.
But it's nice to have an advanced feature that will be available to use easily as a kind of as a library if you're working on Zephyr, even if it's only for the application and you cannot use it in the driver. So this is very cool.
Yeah, that's nice. All right, before we move to hardware, I guess there was a pull request that it's been out there for a while, but in our notes for the podcast, we call it the heap situation.
Yeah,
And
I
yeah, basically
forgot about
malloc
it.
versus kmalloc. Is this kind of like how it boils down to?
This is a bit of a trap that I fell into when I was working on my demo for ZDS last year, and I kind of forgot about it. And then this week I was merging some pull requests, and this came out. Somebody went through the code base. Thank you for doing that, and changed a number of free and malloc to k free k malloc. Why did they do that? So as a starting point, is it good to use dynamic memory on on a microcontroller?
Yeah, I mean, there's
Uh,
a few situations where you have hardly no other choice,
yeah.
right? Yeah,
I mean, you can. I guess if you do it in the right way, it might work. It's probably not a good idea to use it everywhere.
right.
But I presume that yeah, if you have a subsystem that you control and maybe you allocate your own arena and make sure to handle the auto memory situation, and yeah, I guess it worked. But anyway, yeah, we have Zephyr has support for dynamic memory. There's a library for creating a pool, and then there are library function to free and to allocate and free memory from the specific pool. Now, the problem is that we have a bit too much of that, even if you don't quite realize it. So we have two functions specifically that are defined everywhere, which are malloc and kmalloc, and free and kfree. And sometimes we get code in the main repository that use either malloc and free or kmalloc and kfree, and you may think that it's
And
the
I thought
same
like
thing,
I thought that one was the alias for the other, like
but
that malloc was sort of transparently using kmalloc under the
I
hood.
thought the same, but they're not.
Okay.
So here is what's going on. We have two different pools for those functions, which
Mm.
is interesting. The situation I bumped into was I introduced a memory leak in an application. The thing crashed, and I was like, "Oh, it's a memory leak." Yeah. Well, it took a bit more than that, but eventually I reached the conclusion it was a memory leak. And we have some shell functionality to tell you how is the memory, how is the malloc pool doing. So I enable it, I check it, and it says 0. I was like, but I'm allocating memory, and eventually my application crashes. Okay, here's what happens. K-free and K-malloc, which are defined in kernel/mempool.c, they use something called the system heap. And the system heap is sized depending on either a configuration variable called the config heap mempool size, or the sum of a number of config
Hmm.
distributed in the various subsystems. This is so that if you enable a feature, you can have your feature adding a bunch of memory to the common pool. And then you can have every subsystem going like, oh, I want 300 byte on, 500 byte on, blah, 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 and they all get that together. Yeah. So k-free k-malloc is what should be used in the core code. It goes into a pool, and we have a shell command called just heap. It's defined somewhere in subsys shell, which tells you how the heap is doing, how much memory is available. Use that one, happy days. Now the problem is that if you use calloc and malloc, sorry, malloc and free, they go to a different pool, and this is what is called the standard library pool or something. Sorry,
Yeah,
common
the malloc
libc.
arena or something, or like yeah.
Yeah, common libc malloc arena pool. And
Okay.
this one is pretty funny. It's defined by the C library. It's enabled by default if you use libc, pico libc, which is the default.
Mm.
And you can either size it manually, or, and this is the default, is sized automatically to use all the available SRAM. So like your application is going to have the data, when you build your binary, you're going to have the data that you statically allocated, the variable that you statically
Right. Yeah.
allocated. Your stacks, then the linker knows how much memory you have not used, and by default it assigns all of that
Yeah,
to
and I guess
this
the
pool.
rationale is like you port existing code from Linux or whatever, POSIX code or whatever,
POSIX
and it
usually.
just works. it just works. Like you don't
Yeah,
think about like kconfigs or whatever. It just,
exactly.
yeah, you have freeze and mallocs in there, and they
And
use
yeah, until you do something else, and your libc arena shrinks to the point that it doesn't work anymore. And then if you use the shell command to see what's going on, the memory disappears effectively. So this is a
Mhm.
bit of a trap, right? If you're importing library code and you don't realize that it's using the non-prefixed functions, they may end up using an area of memory that you have no visibility about, and I'm not too sure what to do about that. Last time I fixed the samples and I did nothing else. I'm thinking it would be interesting to have the heap command at least report memory on both pools. And you can have additional pools, right? Like probably the good way of using dynamic memory in an embedded system is that you make your own pool and you control it fully. So yeah, yeah, tricky.
But yeah, so I will reiterate. But yeah, thanks to the person who's yeah, helping us make progress on this. This is great. Like this touches a few samples, a few subsystems, trying to be more yeah, consistent in our use of the kernel functions. Yeah.
Mm-mm. Yeah, and if you do subsystem code, use the right macro.
Yeah. So yeah, many switching gears to hardware. We are back at getting yeah, many boards, many boards being merged, and we won't uh, bother you folks with going through all of them. But yeah, interesting new hardware. One, I mean, that's actually a shield that really caught my eye. I had no idea ST Microelectronics had modules and hardware for cellular. But yeah, there's a new shield that just landed for the ST87 M series of cellular and specifically LTE CAT NB-IoT modules. So it's great. I mean, that's more and more cellular options, but it's also yeah, it's news to me that they have such modules. So yeah, it's an Arduino form factor, so you can stack it onto other ST kits or
Eh,
any Arduino board really. So that's cool.
Yeah, and the modem itself is a system in a package kind of thing with the shield and everything. So if you then use it on a board, you can just plop it on the board.
Yeah, it seems pretty tiny too. Like
Yeah,
it's really really a small module.
yeah, pretty tiny,
But
no external components. Yeah, lovely.
yeah, good to see. And yeah, board wise,
Yeah,
a couple noteworthy ones, I guess. The framework
yeah.
laptop
Would,
guys.
would you
What was
rather
it last week?
have
Last week was the keyboard. Now it's an LED matrix.
would you rather have a numpad or a bunch of LEDs on your keyboard, on your laptop keyboard?
I want both.
Oh no, no, you only have one. Well, I guess if you have a backlit keyboard, it's kind of like an LED matrix. Anyway, so framework make laptops, and they make them as modular as they can, apparently. And yeah, if you don't want a numpad on your keyboard, you apparently can have a 9x36 PWM LED matrix with a RP2040 board. Seems like they're
Yeah, I
still
haven't
working
looked in
for
details, but my guess is that you use it for, I think at some point the MacBooks had something like that with, of course, way more pixels. But I guess the idea is that you show some kind of like pixel art for like
yeah.
notifications, like really basic, very pixelated graphics. But
I
that's great.
I
It's
I
cool
I think
hardware.
they just did it because it's cool. I mean, why
Yeah,
not? Like you have some
because you can.
yeah, you have some space on your laptop. What are you gonna do with it? Of course, you're gonna put LEDs. They're cool laptop by the way. They have a modular bay with PCI Express that's times 16 on the back. I've seen people putting a SDR module on it.
Yeah, yeah, and so
But
yeah, it's getting fuller and fuller of Zephyr. Apparently, those laptops. And I think next week, I know that next week at FOSDEM, Zephyr will be sharing a table with the folks from the Drone Code
that's
Foundation,
cool.
and we will be sharing a building with like other cool open source projects, and that includes the framework guys that will have a table as well. So yeah, we will be spending some time with them. It'd be great.
Yeah, they're probably gonna lock all of their RAM in a safe. for the
Yep.
computer.
All right. Way bulkier and way beefier hardware. A new NXP IMX board from Phytech, the Phi board Atlas
The
IMX RT1170. What's
1170.
special about this one?
It has a dual Ethernet. It has a gigabit Ethernet and a 10100 megabit. And when I was searching for the block diagram of the chip, it seems like there may be some variation with three Ethernet. I have never seen any. I like Ethernet. Like this seems to have a lot of connectivity. So interesting board from Phytech. It's actually a breakout board for a module. It seems. And yeah, the module has the RAM and everything. This might be unclear to me if this is a application processor plus MCU or just the MCU, but yeah, lot of connectivity option, and it supports Zephyr. So yeah, if you need that, one more board, good stuff.
Yeah, this one's cool. Yeah, and then there were a bunch of interesting drivers. One thing that, without going into too many details, but I think I saw a bunch of updates from the Renaissance folks, like the RZ and RX, I think as well. They're working on like adding and refactoring some of the stuff. There's also kind of going in many directions here, but uh, both you and I, Fabio, we saw this interesting PR for having and using CAN as a backend for logging. So back to logging from the very beginning. I mean, logging usually it's strings and like and
Yeah,
CAN to me it's more like like
you
raw data sort
you,
of stuff.
you have a payload of 8 bytes.
Right.
So it's a bit unorthodox to use it to send string. In fact, I think there's an extension, there's a common automotive extension, it has a fancy name to send longer
Yeah,
packages.
or maybe you use the dictionary thingy where you don't send the full strings, you only send traces almost. Like I don't know.
Yeah, well, it has a lot of bandwidth, but yeah, the implementation. So it's an interesting pull request. I like to see fancy way of getting logging because logging you probably want you may want it in your production system, right? Unless you're chasing efficiency to the last bytes. It's good to have it for troubleshooting in the field. And I've never seen a logging system on Canvas. The feedback I think from the maintainer is that implementation is a bit too naive. Canvas is tricky. I think there was a comment on reordering frames that should be handled. This just dumps all of the data in frames and queue them to be sent on the bus. So it's probably fairly easy to have corrupted data. But it's an interesting concept. Unclear at this point if this is going to make it to the main repository or if it's going to remain in a separate module. But it would be cool to have one more option, I think.
Yep. And speaking of framing, actually, there's one library we have in Zephyr. It's been, yeah, I don't know, it was introduced maybe a year ago. We might have mentioned it in our various discussions around RPC. But yeah, the library is an implementation of COBS, the basically the consistent overhead byte stuffing, a pretty smart way to solve the issue of, I mean, you have a stream of bytes that you're sending on the wire, and you want to have, I mean, packets, right? And you have delimiters, and then you want to escape. I mean, if the delimiter is encountered in the actual payload of your messages, there needs to be a way to escape them, etc., etc. So it is a pretty nice and smart algorithm for which we have an implementation, and now we have a new PR that's been merged that adds support for actual streaming. So, like if you have data that's coming from your sort of like fire hose, you can do the framing on the fly. So that's yeah, pretty cool addition. And yeah, like if I remember correctly, like whenever a few months back I had this situation where I needed to do RPC at the time on the Arduino Uno Q between a Linux system and my Zephyr-based microcontroller, I ended up picking COBS as the way to do it because it, I mean, it just works. And like Linux side, I picked a Python implementation. On the Zephyr side, it was the Zephyr library, and yeah, it just worked. So yeah, cool stuff.
Nice. Yeah, one more serializer. I'm working on a sample for the embedded controller protocol we use. We
Oh
have
yeah, you mentioned it. Yes.
yeah, I wasn't able to finish it because the Linux side of it is not quite ready. The patch is still in flight, but yeah, well, I'm trying to
Right.
poke the guy that wrote it. It's good stuff.
All right.
More on
Have we
device sharing.
decided what we do next week? So next week we are headed, both of us, to Brussels. I don't know, when do you get in town, and when should we record that thing?
I'm there on Friday morning, and then I'm also
Uh,
gonna be at the meetup in Brussels. We'll
yeah,
find a
maybe
time to
right
record
after that we do something, or like I hope we
before.
will figure out something cool for you guys to listen. Maybe I don't know, we might record slightly later during the weekend, and we'll share some news of things we saw at FOSDEM. But yeah, one way or the other, we will be back next week ish. In the meantime, don't forget to share your feedback, subscribe on the various platforms, and yeah, we will talk again soon. Bye.
See you at then. Bye.